Hello students, welcome to your next video lesson from lesson 8-3. We're sort of continuing our discussion from last time where we were multiplying binomials. Now in this video we're going to multiply some more interesting looking polynomials, potentially of more than two terms. I will say the practice problems I ask you to do are mostly about multiplying binomials with one little extra step or extra thing to be aware of. But we do also in this part of our section have to multiply binomials by trinomials or by polynomials that have more than two terms, three terms, or etc. What we're going to talk about applies to any polynomials that you could ever want to multiply together. Okay, so I'll show you maybe a little crazier example at the end. Just so you can see sort of how this applies. Now, the first example that I want to talk about is very, very similar to what we did before, but if you look over here on the left, we have two binomials that are being multiplied together. The thing to note about them is that this first one has an x squared term, and the second one has an x to the third. So these are not linear binomials. It's not just this many x's times this many x's. Now it's x squared times something with an x to the third. Okay, so we're gonna have to think back to chapter 7 about our rules of exponents while we do this. But beyond that, it's exactly the same as what we were doing last time. Okay, so we talked about the double distributive property. We talked about the FOIL method. Because of where we're gonna go next over here, I'm gonna do this with the double distributive property and sort of show you how that works. And then we'll talk through what's happening here. So I'm gonna take this x squared term first from the first set of parentheses, and I'm going to multiply it by each piece in the second set of parentheses. So I'm going to do x squared multiplied by 2x to the third. Okay, so when I do that, when I do x squared times 2x to the third, there are no numbers on this x squared, so I can assume there's a 1. So you can pretend there's a little 1 there if you want. 1 times this 2 is going to give me 2. And then I have x squared being multiplied by x to the third. Okay, and x squared being multiplied by x to the third is x to the fifth, right? Remember that when we are multiplying x's with different exponents, we add the exponents together. So x squared times x to the third becomes x to the fifth. So this is x to the fifth power. Okay, and then I'm going to do x squared, 1x squared times this minus 3 for the second part of that second binomial. So 1x squared times a negative 3 is going to be a minus 3x squared. Okay, minus 3x squared. And then once I have done that, distributed the 1x squared to both of these pieces, I'm going to, in a different color, distribute or multiply this positive 2 also by each of these two pieces, by that first piece and by this second piece, and get two more pieces for my final answer, which I'll talk about in more detail in just a second. But multiplying this positive 2 here, the second piece of my first binomial, by the 2x to the third, positive 2 times positive 2 makes positive 4. There are no x's on the 2, so it just stays x to the third power. And then the positive 2 multiplied by the negative 3 is going to give me a negative 6 or a minus 6. Okay, remember, I don't really care if you leave it plus negative or if you just change it right to minus signs. So I have my answer here. In our last video, we were combining the two middle terms because they were like terms. In this particular case, we can't do that because there aren't any terms in this 4-term polynomial that are like terms, right? Because in order to have like terms, we need exactly the same variable pieces with the same exponents. None of these have the same exponent. The one thing I do want you to remember, hopefully from the beginning of chapter 8, is we had this idea of standard form. Standard form of a polynomial, remember, had the exponents or the degrees of the different pieces going from big to small. In this case, I'm going 5, 2, 3, and then 0. So I don't really want to leave my answer like this. I want to rearrange things slightly and go 2x to the fifth power, okay, and then take the plus 4x to the third power and put that here. Okay, then take the minus 3x squared part and put it here. Remember, the minus sign always goes with the term it was attached to. And then end it with a minus 6. Okay, So I end up with this 4-term polynomial, 5th degree polynomial of 4 terms, as my product or my answer when I multiply these binomials together. So keep in mind, rearranging things to standard form, adding exponents together when you have those in your binomials, okay? Now, the other thing that I want to show you is this example here, where I have a regular linear binomial, 3m plus 2, being multiplied by a quadratic trinomial, 7m squared plus 4m minus 2. Okay, so this process gets to be a little bit longer than our double distributive property, okay? But it still, in general, is a double distributive property. This one just, we can't think about it in terms of FOIL, okay? So unless both of your pieces are binomials, I need you to put the FOIL method sort of up on the shelf, okay, for right now. Because this needs to be a double distributive property, where I take 3m and I distribute it to these 3 different pieces in this set of parentheses. And then I take the plus 2 and I do the same thing, multiply it by 3 pieces, okay, by 3 pieces. And I'm going to end up with a grand total of 6 different terms, and hopefully I can combine some of those, okay? But this process does add a little bit of complication, okay? It adds a little bit to what we need to be listing out as our product, and potentially more simplifying in the end. So the first thing I'm going to look at is this 3m times the 7m squared. 3m times 7m squared. 3 times 7 I know is 21. M times an m squared. If I think of this m as having a little 1 on it, then m to the first times m to the second is going to give me m to the 3rd power. Okay, m to the 3rd power. So that's what I get from my first multiplication. 3m times 7m squared gives me this. Okay, my next multiplication is 3m times 4m. Positive 3 times positive 4 is going to give me a positive 12. And then an m times another m is going to give me m squared. Okay, so this one is now squared because it's like a 1 and then another 1. Again, we're adding the exponents. 1 plus 1 is 2. Okay. The last for the 3m, I'm going to multiply that by this minus 2 at the end. A positive 3 times a minus 2 is going to give me a minus 6. Okay, and then it's just going to have a regular old m on it because there was no m's on the 2 to do anything with that. Okay, so now I've distributed the 3m to all 3 of the pieces in the other set of parentheses. I'm going to do the same thing with the plus 2. So I take the plus 2, I multiply that by 7m squared. Positive 2 times positive 7 is going to give me a positive 14. And I believe I'm still going to have an m squared on that term because the 2 has no m's to worry about. Doing a positive 2 times a positive 4m is going to give me a positive 8. Positive 8m, right? Because again, the 2 has no m's to worry about, so it just stays with an m. 2 times 4 is 8, 8 with an m. And then positive 2 times the negative 2 at the very end, positive 2 times the negative 2 is going to give me a minus 4 or a negative 4. Okay, so again, I have these 6 pieces that come from this double distributive property that I just did here, okay? So what I'm going to do is I'm going to try to identify some pieces that I can put together. And the first things that I notice is this 12m squared can be combined with this 14m squared. Both of those are currently positive. They both have plus signs in front of them. So a positive 12 plus a positive 14 is going to make a positive 26. Okay, positive 26 m squareds. The other thing that I notice is this minus 6m and this plus 8m, they can be combined as well because they both just have the letter m, okay? So when I combine those together, I end up with plus 2m. Negative 6 plus 8 is plus 2m. Now the 21m to the thirds does not have anything that it can be combined with. There's nothing else with an m to the third, so that's just going to stay there. And then I have this minus 4 at the end that also has nothing that it can be combined with, so I'm just going to have that at the end as well. So here again, I end up with, okay, a 4-term polynomial as my product. Okay, so they both sort of look the same, but the process was different. In this case, I had a lot more pieces that I had to deal with and potentially combine the like terms, all right? Now, as I mentioned, the goal of this is to eventually be able to do something like this. Okay, so I'm just going to draw something out for you real quick. It's going to be pretty simple. If I had x squared plus 3x plus 7, and then I multiplied that by 2x to the third, that's a 3, don't worry about it, minus 7x squared plus x minus 6. Okay, so now I have a 3-term polynomial being multiplied by a 4-term polynomial. As I mentioned, this is not in your homework, but do please hang around and just watch this for a second. This essentially, you guys, becomes a triple distributive property, okay? Because now my first set of parentheses has 3 pieces, and I need to distribute each of those pieces to everything that's in the other set of parentheses, okay? So I take the x squared and I distribute it to this term, 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 okay? So that's 4 pieces right there, and then I do the same thing with the plus 3x. I take that and I multiply it by all 4 of these pieces. Okay, so this is how this would work. I'm not going to ask you to do any of these, except potentially as a bonus question on the test or quiz. But this one is going to end up with 12 different pieces from this triple distributive property that I then have to combine the like terms on and simplify. Okay, so we're not going to go through what all that is, but that's sort of the idea of looking at this double distributive property, looking at expanding our knowledge of multiplying polynomials. Okay, if you have questions, please reach out to me, email, phone, or Zoom office hours. Otherwise, that's all I have for you at this point. We'll see you later.